Phelps, who is the current president of the Society of Neuroeconomics, to tell us what neuroeconomics is.
Oh, I'm going to defer to the founding president of Neuroeconomics, because I think Paul has been instrumental in pushing this field forward, and I'm sort of riding on his coattails a little bit.
I'm going to defer to Danny, who's not here. No. So I'll tell you my personal answer, and I think it's not everyone's answer. I was trained as a neurophysiologist. I learned how to study the activity of single nerve cells in humans and animals making decisions. I learned how to use brain scanners on people and animals. And what I was interested in was decision making, how you pick a wife, how you pick an ice cream flavor. And that seemed to be a reasonable thing for a neurobiologist to study, but it became clear that first off, neurobiologists were ill-equipped, theoretically, to think about that problem. They really were engineers who built wiring diagrams and did not think deeply about mental life, psychological processes, or predictions of optimality theory. And this led me first to psychology, to think about mental life and mental experience, and I realized over the course of many years, and became eventually a professor in that department as well, that you had to combine the insights of psychology, the experimental insights of how people actually behave, if you were with neuroscientific methods, if you were going to develop any comprehensive description of human behavior. Now, that's not too surprising. As I learned more and became driven to sort of understand everyone who had thought about decision-making, it became clear to me that there actually was, at NYU, there's actually a department of decision-making, and that department was called the Economics Department. And that drove me over many years to try and synthesize into my own view the economic approach, which is really, I think, finally about specifying what people ought to do. Psychology is sort of empirically what they do, and neuroscience is how does the hardware achieve what they do, and can it explain the gaps between what they should do and what they do. So for me, neuroeconomics is the synthesis of at least these three disciplines, and its goal really is to adjudicate the gap between economic theory, which tells us so clearly now what an efficient chooser, an efficient person would do, and psychological observation, which tells us people don't do that. And there's a hole there because economics is this spectacular theoretical device that works very well in large groups and works, with apologies, quite poorly with regard to large chunks of individual behavior. Psychology is a good descriptive tool, but it really, at this moment, lacks any coherent, sweeping theoretical view. So you get this problem. Psychologists can tell us what's wrong with economic theory. Economists can tell us what people ought to do, but you don't have a theory of what people do. And it's my hope that neuroscience will fill that gap, and that these three disciplines together will create an algorithmic or mechanistic model of human behavior, which will be able to unite all three levels. And I think that the grand unifying excitement of that, the reason there's so much excitement around neuroeconomics today, at least in my mind, is because that would be a synthesis very different from the one that occurred between molecular biology and biology in the 50s, or between physics and chemistry at the turn of the 1900s. It would actually be a fusion across the border of the social and natural sciences. It would suggest that the kinds of grand unities we see throughout the natural sciences will progress ultimately to the social sciences as well.
So I was interested in understanding human behavior broadly. So I trained initially in psychology and cognition, but then realized looking at the brain was going to be a very powerful way to help us understand cognition. And I retrained in neuroscience. For the past several years, I've been specializing in how emotion changes how we learn and remember. And of course, one of the consequences of learning that something's emotional is that we're going to make different choices. And so I got to this field because I became interested in how what I'm studying about emotion and learning relates to the choices we make. I mean, we assume, of course, when we find out something's fearful or rewarding or something like that, we're going to make a different choice. And when I got into looking at choices, much like Paul found, the psychology of decision-making has merged quite a bit with economics, and that got me into thinking about economics and collaborating with economists. So I came at this more from just the psychological perspective of understanding how it is when we learn things, emotion changes them, and how that changes the choices that we make. And in doing this, I'm just starting to really learn about economics and collaborating with economists and understanding this perspective. And it's given me sort of the theoretical and computational aspects of economics is now adding something to my psychological and neuroscience work that wasn't there previously. So I see the merging of the two enhancing both fields.
Well, I come from a little bit of a different background in the sense I do no research or investigation. I'm a practical economist, having been in that business a long time. But in recent years, when I've read some of this literature, it seems very natural to me, because one of the things I did at J.P. Morgan was participate in the risk management effort. Was basically how to control traders to make them make fewer mistakes, do a better job. And in that process, it was very clear that humans are not good at doing certain things. And it's the exact same things I read in the papers on neuroeconomics. They don't deal well with probability distributions, particularly the tails and small probabilities. They're very associative. They associate one thing with another for reasons that aren't rational, you can say. They're very scenario-oriented. They like to think in terms of a pattern that plays out that is like the real world. They can't separate themselves from that. And all of these things are not very helpful in terms of pricing a derivative security, say, or positioning in the market. You need to be rational if you want to make money in that business. So back in the 70s, we used to try to use ways to train people to be better. For example, we'd ask them to give us probability distributions. This is our best traders. And we would collect them, and we would talk about them, make people think about them, and show them the historical ones. And then we'd come back 6 months later and say, look, you've given me this probability distribution on where the 10-year bond yield's going to be, and 55% of the time, the result is in a box over here that you put 0 probability of happening. There's something wrong here, and you're just not quite right. And we thought this would make them do a better job. And I would say all of this effort in the 70s was hopeless. You'd tell them that 6 months later, they'd come back and do the same thing. And this was the best traders. These guys weren't awful at this. They're actually doing a pretty good job out there. And it really goes to show you what the research says, is that people are hardwired to work in certain ways, and they do certain things well, and they do not do other things well, and it's very difficult to get them to do it. Now, since then, the financial world has moved in ways of just take these decisions out of individuals' intuitive grasp. You've got big computer models, algorithms, which are driving things, and an investment bank would never let some individual in the seat of his pants say, I think that's what that derivative security ought to be worth. It's just not how it's done. You haven't made the people better. You've taken the control away from the people, or you structured it in a way that you've protected yourself from their shortcomings, at least to a large degree. That's how you got these things working better. Not improving the people, but putting up a separate system or structure to do it in. So I sort of come from a world that uses some of these things and experiences them.
Let me put it this way. I was raised as a biologist, and the theory of natural selection is, if anything, the centerpiece of all biological thought. The theory of natural selection says that there are two animals trying to live in the same niche. The one who maximizes his reproductive fitness better wins. Okay, that is actually economics, and where the utility function is replaced by this defined notion of fitness in successive generation, number of your genes that repeat. That is to say, if there were two animals, one of which was a better utility function maximizer, more rational with regard to his fitness than the other, the animal who's the better maximizer wins. And so we would expect to find, after 600 million years of evolution on this planet, that animals ought to be pretty close to good at everything they have to do to survive. And that we believe that the rational choice model would be good predictors of their behavior. Now, in fact, that's true. Every time that this has been taken to the field with animals, it just works perfectly, and the animal's behavior is bang on. When we're talking about individual animals, like there are beautiful studies of birds trying to decide whether or not to grab a mealworm based on the size of the mealworm, how long it takes to uncover the mealworm from its shell before you eat it. You can adjust the weight of the mealworm, and the birds know exactly where the cutoff is. If the mealworm gets one, iota too small, the bird knows to turn it down, because the bird is perfectly optimizing its use of time and its gathering of energy. To me, this stands in stark contrast to the way we understand the decisions of individual humans. I make this a very clear distinction here between microeconomics, the study of individual human decision makers, and macroeconomics, which is kind of what Alberto is leaning on as being so good, and I agree with that. We don't understand the decision of individual human decision makers using economic models anything as well as we understand these birds. You ask people to make simple decisions about losses and gains, and they are petrified about losing money. If I say to someone, here's a lottery ticket, it carries a 50% chance of losing $100. How much do I have to pay you to buy that lottery ticket from you, or something like that? And they overvalue that lottery ticket. It's like they're so petrified of the loss, they'll pay anything to get rid of it, which makes no sense if what they're trying to do is maximize how much money they have in their pockets. Okay, so there is, I think Alberto's got to admit, there's a huge gap in the explanation of individual human behavior at the economic level. Now, this washes out at the market level. That is to say, the rational choice models do great at the market level because you put a couple of billion agents together, and you put a couple of giant investment houses that are using trading algorithms and accounting for 20% of the market in any given instant. And now the markets look really good, and rational choice theory predicts really well. So what I see in economics is a really important gap between the quality of prediction in microeconomics and the quality of prediction in macroeconomics. The good news for economists is it doesn't matter. The bad news for us as as scholars trying to understand human behavior is the first theory doesn't work nearly as well as the second. So that's my fetch.
That will then help us understand, our psychological and economic models. So this has been a debate not just in neuroeconomics, but in cognitive neuroscience and social neuroscience, and any field where you are interested in some aspect of human behavior and trying to see what you can gain from understanding brain function. So we know that understanding brain function gives us another model of how behaviors are organized and put together. It's where behavior comes from. And by understanding things at this level, we're going to get a much more sophisticated and nuanced understanding of the behavior itself.
And there's arbitrage. There's all kinds of reasons why an economic system, particularly a finance system, can produce a rational result with irrational people underlying it. And I think economists shouldn't be criticized too much for those rational assumptions on there. But there's a lot of other areas of behavior where these conditions don't hold, and there isn't any arbitrage. There aren't large numbers. Take designing a system for cars that would make them safer. Warning systems, lane thing, all kinds of things that it's very critical how the mind works and how humans behave. And it's very useful to know these things when you're thinking about what system in a car would improve it. Or the big problem in medical care of how the error rate. Flying an airplane, you never accept the error rate you're getting in hospitals now. Why is that? How do you reduce it? Well, you've got to structure the way people do that. People behave wrongly. So I think there's all kinds of areas outside of sort of finance or traditional economics where knowledge of how the human mind works can be very useful in designing solutions.
So we should get back to the two brain or the two people, whatever, the two people inside your head debate at some point.
Okay.
But for instance, we did a study where we had people learn through trial and error to trust somebody or not trust somebody. So somebody's going to reward you, they're not going to reward you if you trust them in an economic exchange. And prior to them doing this, we then gave them a little vignette. This person is basically a good guy, nothing to do with economic behavior, but kind of helps his friends out, that kind of thing. Works for Teach for America. This guy's kind of sleazy. This guy's kind of average. What we see when we do this is when you're working with the good guy, you don't use the part of your brain that seems to be responding to trial and error feedback. that you're getting through these economic transactions. Okay, you use another learning and memory system. That's one learning and memory system. Use another learning and memory system when the guy is good to help you guide your choices. And your choices don't change as much with a good guy, even though they're all rewarding you to the same degree. Okay, so you can say, well, maybe we would have seen that in behavior, and we did. Okay, but we know something about how those brain systems work and what kind of information they encode and what kind of information they use when they're when they're driving behavior versus another memory system's driving behavior. This now tells us something about the psychology that we wouldn't have known otherwise. We can take everything we know about those brain systems now and use that to understand why it is when it's a good guy, it doesn't bother you so much that he cheats you. And that's going to now go and inform our psychological model of how this could work. So that's just an example of how it is seeing something in the brain might then change your psychological model, because we're bringing everything we know about the brain science to that psychological model in that case. And ultimately, we care about what people do. We care about that level of description, right? But knowing this other level of description adds information to this level of description.
Well, one of the things in the paper is that if you give somebody oxytocin, they become more trustful. So what are you going to do? If you want to cheat them, you give them oxytocin and then have them trust you and take their money? I mean, it seems like the finding doesn't lead you into a place where you have a solution to the issue. So oxytocin, yes, increases bonding of the mother and the child, increases trust. It does a lot of nice things. And a lot of opioids do a lot of nice things, as we were recently finding out. But how does that help us in terms of determining affecting the person's economic behavior, which is what neuroeconomics hopefully will one day do, no?
I don't know, that's not my goal.
Yeah, I don't know if that's a goal, but
There's actually an answer to that. They've shown, economic studies have shown that societies, cultures where the trust level is high do much better in terms of everybody else's welfare.
Yep.
No, but what are you going to do?
Give everybody his question.
You're not going to, what are you going to do? Give them the hormone?
No,
Give a society hormones?
That's a question for culture, but you know the biological effects
Yes.
of cultural change you make.
Right, but economics has to do more with culture than the biology of an individual.
Well, that particular question, yeah.
And, the first 5 or 10 years, you could easily argue we didn't learn a whole lot about the study of cognition from studying the brain. Certainly, since then, I think almost everyone would disagree with you. And so I think this field's very, very young, and I think we'll start to see where this is going to benefit economics, and in ways that I don't think we can predict right now. Certainly psychiatry, we can't argue this hasn't had a huge influence on things like psychiatry and other fields, and I think that's going to be true for economics in ways that may be hard for us to answer today.
The oxytocin result's really striking. To me, what it means is a behavior as complicated as trust can be reduced to a single hormone, at least to some degree. That's an amazing
Neuroscientific
finding. And by understanding where all the oxytocin receptors are, we can leverage that to even understand a little bit more about the neural basis of trust.
Very important.
Let me just finish for one more second. And so all of those are good. And if I can show you that those brain areas are active during some other kind of exchange, I can relate that new behavior to this underlying neural circuit, and that allows me to improve my model of that behavior as well. Does this mean we should make everybody carry nasal inhalers and use them every hour? I don't know. You have to ask a welfare economist that question, and I'm definitely not a welfare economist.
And I think the neuroscience evidence doesn't support that. It suggests a much more subtle and nuanced view. Emotion's not one thing. It's not represented in one way. These systems that, underlie emotion and cognition aren't independent in the brain. There are brain structures that are more or less involved in emotional behaviors, but they interact extensively at every level of analysis with those that are considered cognitive behaviors. So it just seems to say that this dichotomy that we've used to understand psychological behavior, and it's been very helpful in driving the field forward, it is taken, and now we have it in these two parts of the brain, completely takes away what neuroscience is bringing to the table. Neuroscience, is going to give us a much more subtle and nuanced nuanced view of how these things work. And that's going to go back and now refine our psychological models. And it doesn't mean they're not good psychological models or they aren't important psychological models. You know, right now they're just somewhat incomplete in understanding all of human behavior, which is expected as the field progresses.
From the other side, so I made at some point the example of the glasses, and I said that's rationality. That was supposed to generate the reaction that, you know, we have a very stripped down notion of what rationality is, which has been incredibly powerful on one hand, but of course it's incredibly reductionist. So it seems to me that what they are doing, what neuroeconomics is doing, it's actually going the other way to enrich the notion of rationality that we put into our model, as opposed to what the question seemed to imply, to not be rich enough. I mean, the notion of rationality we use is extremely simple and small, and what they're doing, it's just enriching it. So it seems to me the other way around. But
I mean, to be honest, economics, macroeconomics, all the things we explain, how markets work, how GDP grows, is not solidly grounded on how an individual makes decisions. It is not. At the macro level, it has a life of its own. And therefore, economists tend to be willing to say, oh, let's say there's two minds and could be interesting. You know, sort of the economist joke, let's assume you have a can opener and it'll be all right. Economists are quite relaxed about it because it really doesn't build up. And you change your understanding of how individuals work. Economics doesn't rise and fall on this. Macroeconomics, most of economics, it's not really grounded on those individual behavior.
You've alluded to this. I'd like to know, what is the experiment's agenda for neuroeconomics? You talk about subtlety and nuance. What are the 3 or 4 experiments, the Michelson-Morley electron experiment? What are the kind of experiments that you think are going to really make these people sit up and pay attention? Not unlike the way that Danny Kahneman and Tversky, the framing experiments, you know, the Herb Simon stuff, subjective expected utility, you know, affected and influenced, quote unquote, rational choice in economics.
Here's the real answer is the goal is the generalized neural theory of decision. Okay, that is a piecewise explanation of the architecture of the brain and how those elements interact computationally to yield free human choice behavior. I want a generalized neural theory of decision making in the same way that we have a standard model of the atomic structure of the universe, which again, we don't need. I grant you that. But I love that there's a standard model of matter. I don't know.
Neuroscientist.
Yeah, I'm a neuroscientist. Alberto knows exactly what I think is the candidate experiment, and it's one to explain this impulsivity. There are going to have to be a series of neuroscientific experiments which yield novel behavioral predictions. This is really critical because what you're saying when you do that is, I can use the mapping and a study at the neuroscientific level to make a behavioral prediction that has never before been made by an economist, and that an economist would not have thought to make. That behavioral prediction has to be validated, and then the last piece to make this a home run is it has to undermine a major axiomatic theory.
That's important.
And suggest an alteration to that axiomatic theory. As Alberto knows, there are 2 groups in my lab working on experiments that have this flavor. They may or may not succeed. These are the experiments that are really going to, I think, make it impossible to look away. It's a question, as Alberto said, of defining what's in the utility function. That's the whole point. George Lowenstein, a noted economist and psychologist, has once gave me this puzzle. You go off to one of your graduate students goes off to a conference at some remote city. She's engaged. And she meets some nice guy, and they go out to a bar. And she's sitting at the bar trying to decide whether or not to go back to the hotel room with this guy. And she does. And then she wakes up the next morning, she's completely distraught and miserable and crying. And so how do you explain that? Because that was an irrational act. And George has argued to us that that's because something emotional takes over control of her behavior, and the rational is part of her. Now, as a biologist, here's my read on that. We evolved to maximize fitness. She is just doing exactly what she was designed by evolution to do. And
How come half of them may do and half of them may not do? Is evolution that...
No, so then I have to explain to you something from game theory called a mixed strategy equilibrium that requires unpredictability in behavior in order to maximize welfare of the agent. So there's a very good answer, but it would take a little while to work through.
I think so, but I'll take your word for it, because I don't think you have the answer.
But this
I
is
think
not-
the only way you can have that answer is if you have the patient in your office, and then you can draw the line that will explain to you why this person did what she did, and another person, very similar in many ways, did not do what she did.
So to me, that is a parallel, even an equivalent perhaps, explanation to the game theoretic one.
No, but
Okay, let's...
we can't do it forwards, only backwards.
Yes.
If the person comes in and says, I was so tempted, but I didn't.
We can't
listen-
predict.
We can do it forward in the aggregate.
In the aggregate, you
Well, we
can do it
can't
forward.
predict.
And in mammalian models and in bird models of monogamous animals, you find this, what you just described.
Sure.
And you find it in human societies too. So that means that there's a biological possibility, a propensity, but it doesn't mean every single person would succumb without many drinks
This
of
may be
vodka.
helpful. There's a very, very famous puzzle by the economist, physicist, everything elseist, John von Neumann. Sherlock Holmes is in Victoria Station in London. And he jumps on a train, which is going to stop at Canterbury on its way to Dover. And he knows that Dr. Moriarty, his arch enemy, has got to the station just after the train is pulled out. So he's okay on the train. Moriarty has a gun, and he will kill Holmes if he can find him. So here's the decision Holmes has to make. If Holmes gets off at Canterbury, I left out one other fact. Moriarty's rich, which you're supposed to know, and he can charter a train. But he has to know where to stop. Because if Holmes gets off at Canterbury and he shoots to Dover, he'll catch Holmes at Dover. But the opposite is also true. So what is Holmes to do? If Holmes says, well, here's what's going to happen. Moriarty is going to think I'm going to Dover. So I'll get off at Canterbury. But of course, Moriarty is smart enough to know that, right? So he'll work through that same logic, and he will also go to Canterbury. By which logic, Holmes should, of course, then triple cross him and go to Dover, by which you get this idea. And so the solution, I'm simplifying a tiny bit from the way von Neumann presented it. Von Neumann argues what Holmes is actually supposed to do is flip a coin. That the safest thing he can do is flip a coin. There's a 50% chance he'll get out alive. And a lot of games have this quality, although they don't require an even coin. It's often true that a weighted coin gives you a better yield. So as an evolutionary biologist, here's my answer. In the aggregate, 30% of the people should do this. This can be predicted by game theory. Now you ask a great question, which is what is the psychological and mapping one step down neurobiological instantiation of that randomization process, or the social instantiation of that randomization process? I am deeply interested in that question. I think we want to be able to answer that at all levels. The reason I have spent the last 7 years trying to become an economist, and the 7 years before it trying to become a psychologist, is not because I believe neuroscience will subsume economics or psychology. In fact, if you read my papers or my book or any of the things I've written, what I hope you'll see is that all three of those levels coexist in good theories. And my interest is in no way to replace economics. If I was going to do that, I would not certainly have wasted the time to be considered an economist by my colleagues, to try and publish in economics journals. My goal is to understand this process of our behavior in as many different ways as possible, because it is my conviction that understanding it more ways is more powerful than understanding it less ways. When all is said and done, what you want is an explanation at every level and as many ties between those explanations as you can get. They'll be incomplete. The mappings won't be perfect. That will be the strongest explanation of human behavior. Walling off these disciplines, which is the alternative, strikes me as, ostrich head in the sand. My discipline's fine. Now, neurobiologists mostly believe that. Don't get me wrong. I came from a tradition where they said, when I wrote my first economics paper for neuroscientists, it was, Nature wrote back and said, are you out of your, mind? You want to write a utility function in a neuroscience paper? That is a waste of time. Neuroscientists understand choice completely, and we know exactly how to study it. And ties with economics are a waste of time. So, I feel so passionately about this because I spend so much time on it. I am not in any sense trying to replace economics or psychology. I am trying to unite them with neuroscience.
In New York, one of the speakers earlier said that people had evolved over hundreds of millions of years to make rational choices. And I think it might be more precise to say that collections of genes have evolved over hundreds of millions of years to make optimum choices, and that those optimum choices for collections of genes might involve irrational choices or variants from rational choices by individuals bearing various portions of those collections of genes. I wonder how the speakers in any way feel they can adapt the rational choice model to speak more broadly to the collections of genes. And in particular, are there any particular cultural, ethological, or other ways of grouping human behavior so that you can see variance in a broad way across those cultures or groups in the way decisions are made?
Anybody wants to tackle that question?
Yes, I really thought about that.
I assume you're thinking of Richard Dawkins' powerful ideas about the selection occurring not just at the level of species, as Darwin had originally proposed in the 1860s, but occurring at the level of individual genes. And of course, we now know that selection occurs not just at the level of individual genes and whole species, but gene clusters. The evolution of data now about the hat maps and stuff like that seem to indicate that multi-gene loci evolved together. I spoke too quickly when I said that. Selection is definitely occurring at many levels, for sure. As a back-of-the-envelope model, we could take Darwin's and think about selection at the level of the species. It is certainly not the only level at which the selection occurs. And one thing that's striking about this is that some behaviors which appear irrational, when we think about what people tell us verbally they want, this is natural for an analyst, I assume, make perfect sense when we look more broadly either at the individual's welfare or look at a species, groups of behaviors. Some of them won't explain easily this way. So the idea I want to get across is rationality in the economic sense is about maximizing utility function. What goes in the utility function is a little underspecified. And one of the things that we might begin to think about when we think about utility functions is our evolutionary heritage. That's sort of the point I wanted to push. And I want to back away from selection at any one particular level, whether at the meme level, the DEEM level, the individual gene level, the hat map level. All of those things are going on, of course.
Are there any experiments which show variation across large populations of these kinds of rational decisions?
There's a great experiment that's unpublished by Reed Montague's group at Baylor College of Medicine. And in this experiment, Reed has his subjects play what looks loosely like a game. For those of you who grew up in psychology departments 20 years ago, what they're actually doing is an experiment of Richard Herrnstein's, of the Harvard psychologist Richard Herrnstein's. They're picking between two levers. The levers pay off money with probability distributions that are a little complicated. It turns out that there are two good solutions to this. One solution is to half the time push the left lever and half the time push the right lever, basically in random order. There is a better solution, but it's hard to find. What you have to do is push the left lever 9 times for every 1 time you push the right lever. The reason this is hard to find is that all the intermediate ratios stink. And it turns out that only half of Reed's subjects find this better solution. Half do and half don't, just odd. So they drew blood from these people, and they genotyped their dopamine receptors. And it turns out that all of the people that find the best solution have a particular isoform of the dopamine D5, if I remember right, subtype of receptor gene. And this particular isoform seems to be associated with propensity towards risky behavior.
Okay.
The intellectual power that's represented at the table is overwhelming. I'm overwhelmed by it, and maybe some others. And yet it goes off in so many different directions, it's hard to focus, as you will appreciate. And I also appreciate that it's very difficult to focus on any one thing given what's at the table. It's too much to expect from it. At the same time, I want to make some random comments rather than anything terribly focused. My name is Michael Grupp, and I've spent my time in ethics and moral theory for the last 40 years. And I'm coming out of retirement now to think again, which is why I'm here. I'm remembering a philosophy professor. When you make the comment and you tell us the story of Sherlock Holmes, one of my great heroes, and Moriarty, his arch enemy, and you say that he flipped a coin, you should have flipped a coin in order to make a decision as to what the best thing was to do. There's a professor by the name of K.D. Arani, as I remember him, City College, poor man's Harvard at the time. And Arani stood there like this, and we were discussing free will and determinism. He had his finger out like this. And he said, which one of you can tell whether I'm going to do this or this with that finger? And there was all kinds of debate and discussion for the next 3 or 4 weeks on the topic. And he ended up by saying at one point, which impressed me a lot, it's still with me, and I'm bringing it here to the table. If we knew everything about K.D. Arani, everything, we could predict what he would do. At the time, there was no discussion of neuroscience. I never heard the word before. I knew they were neurons, but I didn't know what they meant. Now you're describing them. This was some time ago. So I begin to wonder what you mean when you say that you, sir, Paul, that's the name I have, want to understand everything there is. When I sat behind you, I couldn't stop the challenge at the moment. To me, it was a challenge. As to why it is that you want to know all these things. What is it that you're interested in to know? And that goes for all of you at the table, and me too, about living in the real world. What is it you really want to know? And why do you want to know that? And then I heard the word control mentioned once or twice. And from the sociological point of view, I left it alone, because I was concerned that we'd be talking about a totalitarian question, which wasn't at the table, and I didn't really want to introduce it, yet I do. Where do you want to go with all this? Maybe this is not the time to answer all that. But here you are in the various university disciplines promoting ideas and organizations, promoting ideas with what in mind? Where is it going to go? Vance Packard, you may remember. Some of you remember that book, The Hidden Persuaders, and I think it's from that book I quote. Subliminal. Do you remember the word subliminal? You still use it? I don't really know. As I say, I'm not sure it's used anymore.
Yes.
But the question was, from the economist's point of view, how could you sell more Coca-Cola? That was the issue. Economics, economicus, in the movie theater. And so what they did was to put the subliminal phrasing on the bottom of the screen below your consciousness level, but within your framework of reaching you in some level. And during the intermission of this very dull movie, sales of Coca-Cola went up 50, 70, I don't know how much percent. Because you were approached at a way of understanding through your neuroeconomic content, however you want to describe this now, biologically, psychologically, psychoanalytically, Dr. Nersesi, whichever way you wish to go. You were going to change the behavior of people. And what I wanted to know, and what you have to ask, it seems to me, as moral agents, which you are, because you are teaching people what they should be thinking about and making every effort to convince them that your position is a good one. The interplay between you two gentlemen is wonderful. But it masks something, I would suspect. I think it masks the difference between you and making authority in the world, up to a point. And that's all right. We're all there. So I didn't get up to scold. I feel like I'm scolding. I don't mean to scold. And yet it concerns me a great deal about what you mean by control. And that's the deeper issue. You're now about to give another tool to the community that will give somebody an opportunity to have control over what I purchase. And if the box of Tide comes in a blue box, I'll say it's good and mild. And if it comes in a red box, I'll say it's harsh. I don't like the chemistry. And if it comes in a yellow box, I won't buy it anymore because it burns my hand. I could go on indefinitely. I stop at this point.
Thank you.
Mine is just an observation.
Thank you. Does anybody?
Which I'm on the board of, which was formed to try to address some of these questions. So things like what you would call neuroeconomics has been exploited, I guess, by people who are interested in marketing. And there's companies that now sell neuromarketing in the field of law. There's companies that are selling, brain science to look at lie detection and things like that. And all of, I can't speak for everybody. For me, and I'm pretty sure for Paul, our goals are actually as basic scientists to understand how things work, knowing that this will then be applied, hopefully to the treatment of things like psychological disorders, where they're actually helping people. But of course, when you have more knowledge, it can be used now in ways that perhaps society wouldn't be so happy with. And this is not just, this is genetics and physics and all sorts of sciences. And so, so you're saying what our goals are. Again, my goal is basic knowledge. I'm a basic scientist. I don't do my science with a specific application in mind. But I don't think neuroscientists are walking away from these issues and these debates. There has been a large growth in neuroethics and interest in neuroethics over the last 5 years. The Society for Neuroscience has an annual neuroethics lecture. Again, there's a Society for Neuroethics that's formed that is starting to have their own conferences. The American Journal of Bioethics now has a section every month on neuroethics. So these issues are emerging, and how people will use this science is something, again, that we can't necessarily control, which is true of all science. We think it's going to be for good, can't guarantee it will be for good. The best we can do is be part of those debates, talk to the lawyers who are now dealing with court cases where everyone has a brain excuse, for their behavior and what that really means and doesn't mean.
I'm Michael Sachs. I'm a retired attorney. And I've got a question that's primarily directed to Bill Brown, which has to do really with empirical data and its development, which has to do with what's really going on in our financial services firms, the investment banks, the hedge funds, the private equity funds, in terms of having both their own economists, their own mathematicians, developing their algorithms, studying the actual performance of the markets, and whether or not to some extent, both the thought that's going on there, the data that they put to use as a matter of applied economics, and presumably the continuing data that they gather over time is sort of an untapped source of information regarding macroeconomic behavior, which might in the end have some microeconomic connection as well.
Well, certainly there's a huge amount of effort that goes on in these financial firms. As was mentioned, there's a lot of resources, and there's returns from doing this work. A lot of it is not. Economists probably have a smaller and smaller portion of this work as opposed to other people with other quantitative backgrounds that aren't necessarily economics or either finance, but the definitions, the dividing lines aren't very clear. Anyway, there's certainly a lot going on. Data has been, for a long time, going back 20 or 25 years, financial firms recognize the value of data sets. Having information on pricing, having information on a whole range of things, defaults, is useful things and you could make money on, and that if you have it, you have an advantage over the other people. So effort has been put into collecting data on different aspects of things. The question of whether it's useful to, at a truly macro level, I would be hard pressed to find good examples of that. I certainly know where it's been tried. If when scanning things came in stores, the question is, okay, you're at Walmart, you get all this scanning data. This is hugely good stuff. Economists can do things, we can explain a lot, the macro. I wouldn't say that's an area that's produced a whole lot. It's probably produced less than people thought. There's a whole set. I think most of the work is pretty just straightforward. You can make money by predicting how many home loans will be repaid in each zip code in the United States. That's not a very interesting question but from a money point of view, that's our biggest financial market is mortgages, and prepayment rates make a huge difference to their value, and there is a lot of guys out there trying to predict prepayment rates for each mortgage. So there's a lot of that.
Notoriously irrational market, as it is.
And it's very
very ill-predicted.
Very difficult.
But in developing that kind of data, are they looking back in time to look at prior experience and therefore private behavior within the various zip codes? So in the core, isn't there really some information regarding the behavior of individuals?
Yes, I mean,
in the mass.
Yeah,
right.
Sure, certainly. And I'm sure access to that data is of interest to academics and people with other interests than the firm, and I'm sure that happens at some level.
Thanks.
Yeah. My name is Eric Hooks, and I've been many things in my time, as they say in The Man Who Would Be King, most of which are best left unsaid. So, having been a foot soldier in the military and a trader, I was a currency trader. I was self-employed for a while, and I'm very keenly aware of the significance of information and access to it. And I did take a medical ethics course a long time ago, and I certainly appreciate, how significant the issues you raise are, and also, as you yourself suggested, Paul, just information, the pursuit of information, and if you have it in its entirety, and hopefully you're able to show some sunlight on all aspects of it, I think that addresses some of the ethics questions, hopefully there. But I was curious because I took decades ago when E.O. Wilson's book first came out, before social biology was a dirty word, and they had to change it, to evolutionary psychology.
We still use it.
Okay, well, you're in the ivory tower, so I guess you can get away with it. But
as you know, Wilson got a picture of ice cold water.
I know.
Dumped on
I
his
think it was
head
right after
in the
that time
ivory
they started
tower.
changing the word. I saw him about a month ago, in coinciding with the release of his collective works and stuff. But since you have essentially made such a pretty package here in actually talking, without naming the word consilience, again, and I'm not sure how many people are really prepared for that.
I tell you, my book, the last paragraph ends with the word consilience.
It does. It does. I mean,
available for purchase.
Okay, I thought it was fascinating because his book, when it first came out, had devoted some 500 plus pages to what you observe about behavior in nature, and clearly nobody goes to school for that, nor are they given maybe parental pushing verbally in a direction for choice making. But in the last 30 pages, of course, are incredibly controversial. But since this is an area that you're living, perhaps you can do your bit publicly here for some of the notions that he was addressing and is your final word in your book.
He's my hero, flat out. As a biologist, as a sociobiologist, I think Wilson is just one of the greatest thinkers of the last 100 years. Like one of the 5 or 6 most important thinkers of the last 100 years. In Consilience, what he argues is exactly what I believe, that there is a tremendous amount of unity between fields of knowledge, and that what has happened in the last couple of 100 years is we have revealed, starting at the really easy stuff like quantum physics, we've revealed the unities that connect knowledge at different levels, and it's his conviction that we'll be able to draw parallels and mappings as we move up even to the level of whole social systems of behavior. And what he argues in the book, very, I think, eloquently, but I guess not everyone drew that conclusion, was that the really big challenge is the gap between the social sciences and the natural sciences. And bridging that gap is going to be really, really hard. At my university, there is a dean for social sciences and a dean for natural sciences, and those are 2 separate divisions of school. We're working on that problem. Is basically the issue.
Everything's subsumed under biology.
No, see, I don't think that can happen. I know you're daring me. I really. No, look.
Not going to happen.
Look, the reason you know that won't happen is because there is still a Department of Chemistry. 110 years ago, a bunch of chemists and physicists had this battle about whether physics was going to become chemistry. Quantum theory emerged. It unites physics and chemistry, for sure. Both of those disciplines rely on it. Guess what? You still have to pick whether you want to be a professor of chemistry or physics. So do I think, do I hope, 100 years from now, there'll be mappings between psychological levels, economic levels, neuroscientific levels? I'm convinced there will be. But I think you'll still have to pick what you want to be a professor of.